identify all of the components over an ellipse in its general form, as with other conics, first off, we have to rewrite it in standard form. So to do that, we're going to follow the next steps. First off, we're going to group the variables. So first off, write either all the x variables, all the y variables, doesn't matter, but first, let's group them. So first off, I'm going to write all of the x components, then all of the components that have a y term, and everything that doesn't have a variable, that is all the constants, are going to go to the right side of my equation. Now, we're going to factorize individually the terms of each variable. So for example, for the terms that have the x variable, I know that they have a common factor, a constant common factor. That constant is 4. So I'm going to factorize that constant. And for the y variable, all of these are multiples of 9. So I'm going to factorize just the constant. Y squared plus 10y equals minus 205. Now, my next step is to complete squares. So, if I want to complete squares, I know that this is going to look like my linear term divided over 2 and raised to the power of 2, and that is 4. So if I complete this square, it's going to look like this. And if I complete the other square, this is the linear term over 2 squared. 10 over 2, 5 squared, that is 25. Now, here is the important part. When you completed squares, you know you have to add things on the right side of the equation to create a balance. But remember, in this case, when you completed squares, you got a 4. That 4 is also affected by this factor. So instead of just adding a 4 on the right side, you're going to add 4 times the factor, that is 16. And the same thing applies with the other variable. You completed a 25 here, but this 25 is being affected by this 9. So 25 times 9 is 225. So that is what you have to add on the right side. From here on, we just have to simplify the right side and transform this into binomials. So this is x plus 2 squared plus 9, remember, square root of the first one, sine of the second one, and square root of the third one. Square root of the first one, sine of the second one, square root of the third one. And on this side, I have 225 minus 205. That is 20 plus 16. This is 36. So the last step we have to do is to divide the entire equation by a number that makes my right side 1. So obviously, if I divide everything over 36, I'm going to get on my right side 1, and on this side, I'm going to get 4 over 36, this is 9. And on this side, 9 over 36, that is 4. Or, in other words, actually 1/4. So that's why we write this. So that's how you create that's how you transform an ellipse in general form into a standard form. Let's do one more example. So first off, I have to group my variables. So first off, everything that has an x, then everything that has a y, and all of the constants to the other side. Now we're going to factorize each set of variables. For the x variable, they have a common factor of 4, so I'm going to factorize a 4. And for the y variables, well, the constant factor is just 1, so there's actually nothing to factorize there. Now I'm going to complete my squares. I know that on this side is 6 over 2 squared, this is 9. And for the y variables, this is minus 2 over 2 squared, this is plus 1. So to complete my right side equation, I'm going to add on the right side 9 times 4, that is 36. And on this side, this is 1 times the factor that it was 1, 1. So in this side, if I condensate this trinomial into a binomial, this is x plus 3 squared plus 1 over y minus 1 squared. And on the right side, we have minus plus 1 plus 36, so this is just 36. And the last thing we have to do is to divide everything, so the right side is 1. Because my right side is 36, I have to divide everything over 36. So that gives me x plus 3 squared, and 4 over 36 is 1/9. And 1 over 36 is just 1/36. So that's we get this ellipse in general form, and we can start obtaining all the data we want.